Hello everyone, and welcome to the latest fractions maths lesson where we're looking at subtracting two mixed numbers today. Our words of the day are still about those important denominators. Remember, you should be practicing your Roman numerals as well. So what is the date today? Remember what those M's, X's and I's mean. You might be thinking about your V's and your L's and your D's. What do they mean? Do you know any other Roman numerals? Okay, so our warm-up questions today are going to be recap questions like we did last week. So let's have a look. So cake is eaten at a birthday party. Each cake is cut into 8 pieces. 25 pieces are eaten. There's an S missing there. How many whole cakes have been cut? So you need to think about whether the answer is A, 4, B, 3 and 1/8, C, 25 eighths, or D, 3. Okay, so let's work through this because we're looking for how many whole cakes have been cut. So we have 25 pieces that are cut into 8, so that would be it as an improper fraction. If we're looking for how many wholes, so how many 8s in 25, there's 3 8s in 25 because 3 times 8 is 24, and then we have 1/8 left over. How many whole cakes have been cut? So there's 3 wholes and 1/8 of a cake that have been cut. It can also be represented in improper fractions. So it's definitely not D because more than 3 have been cut into. I suppose we do have 3 wholes and 1/8, so lots of those different answers are applicable because you've cut into 4 cakes. 3 and 1/8 is the same as 25 eighths, and you only cut up 3 whole cakes. So that one is one with multiple options. Number 2, what mixed number is shown by the diagram on the right? So how many wholes have we got, and then how many fractions are left over? So just pause and decide whether you think it's A, B, C or D. Taking care that it does say mixed number. Okay, so we've got 1 whole, 2 wholes. We can see they're split into eighths. So 2 wholes and 1, 2, 3, 4, 5 eighths shaded. So D is the correct answer. Convert 3 2/5 to an improper fraction. So we've got 3 wholes, how many fifths in 1 whole, and then add 2/5 at the end. So remember our method, which was actually, give a little pause and then I'll talk through it. So do you think it is A, 11/5, B, 15/5, C, 17/5, or D, 30/5? Right, so hopefully you've chosen A, B, C or D. So our method was whole number times the bottom number, the denominator. So 3 times 5, which is 15, add 2. So 15 add 2 is 17 because it's the same as saying 3 times 5/5. So 3 lots of 5/5, which equals 15/5. And then you need to add your 2/5 on the end. So just a slightly quicker version is whole number times denominator plus numerator. So the answer is indeed C. Okay, we've got some warm-up questions here. 4 minus 1, and then we have those 3 other questions which are slightly different to each other. So we have integers, whole numbers, we have proper fractions, we have mixed numbers, and we have improper fractions. So pause the video and have a go at those. Okay, so the first question is just 4 minus 1. That represents when you are taking away fractions and the denominators are the same. So if you had 4/6, take away 1/6, all you really need to worry about there is the 4 take away the 1. So 4 minus 1 is 3, much like 4/6 take away 1/6 is 3/6. So 4 take away 1 is 3. The next one, proper fractions, so the numerator is smaller than the denominator. 7/12 take away 1/6. You need to make those denominators the same, so make them into twelfths. 1/6 is the same as 2/12 because you times on the bottom by 2 to make it equal 12, and whatever you do to the bottom, you do to the top. So then we're back at subtracting our fractions. Now the denominator is the same, so all we're basically doing is we know the denominator has to be 12. 7 minus 2, which is 5, so the answer is 5/12. The next one, slightly different again because we've got our mixed numbers. So we've got our 4 minus 1, which is 3, and then we've converted this 1/6 into 12, so 6 times 2 is 12. Whatever you do to the bottom, you do to the top. 1 times 2 is 2, so we have 7/12 minus 2/12, which is 5/12. So the answer is 3 and 5/12. The last one, 55/12, take away 14/12, and then we could put it into a mixed number at the end. So we're just doing 55, take away 14, which is 41. So how many 12s in 41 to make it into a mixed number? We have 3 12s, which is 3 12s is 36, and 36 plus 5 is 41. So 3 and 5/12. Right, let's look at today's questions. So 3 and 3/5 minus 1 and 8/15. Remembering, make those denominators the same. So we're going to separate out the wholes and the fractions. So we have 3 minus 1 for our wholes and 3/5 minus 8/15 for our fractions. So 3 minus 1 is 2, that's the whole numbers. So we can then cross them out, and then we've got 3/5 minus 8/15. We need to make those denominators the same, don't we, before we can do anything else. So 5 multiplied by 3 will make the denominator the same. Whatever you do to the bottom, you do to the top. 3 times 3 is 9. So then we have 9/15, take away 8/15, which is 1/15. So the answer, bring your whole back in with your fraction, is 2 and 1/15. So separate out those wholes and those fractions, and then calculate it, making sure to make the denominators the same. So pause the video, just make sure. Oh no, we're just going to have a look at this one before you do a different one. So just a different method here. So 3 and 3/15 minus 1 and 8/15. We know that that's the same as 3 and 9/15 minus 1 and 8/15 from the last question. So we're just going to represent it visually here. So we've got 3 wholes in 9/15, which is the same as 54/15 and minus 23/15. If you count up all the parts, take them away, it's 31/15, or 2 wholes and 1/15. So it's the same answer as last time, just representing it in a different way, and whichever method you prefer is the one you'll end up using. Okay, so here is where you pause the video and have a go at these questions on your own, remembering to separate out those wholes and those fractions. When you're doing the fractions, make sure that you make the denominators the same. So pause the video and have a go at those, and then check with my answers. See if you can spot where you made a mistake if you don't get the same answer. Okay, so look at the first one, 5 and 9/14 minus 3 and 2/7. Let's make those denominators the same. 2/7 is the same as 4/14 because you times the top and the bottom by 2 to get the same denominator. So then we've got 5 and 9/14 minus 3 and 4/14. So I've split those out into the wholes and the fractions. So we have 5 minus 3, which is 2, and 9/14. Take away 4/14, which is 5/14. Okay, let's look at the next one. So 2 and a half minus 1 and a 6. Let's make those denominators the same. So we're going to make them into sixths. So you get from half to sixths by multiplying by 3, because 2 times 3 gets you to the 6. Whatever you do to the bottom, you do to the top. 1 times 3 is 3. So now we have 2 and 3/6 minus 1/6. We're going to partition them. Oh no, we're going to do a different method this time. If you partition them, you do 2 minus 1 and then 3/6 minus 1/6. But we're going to visualize them with our bar model this time. So we have our 2 wholes and our 3/6, and we need to take away a 1 whole and a 1/6. Remember, you can also count up the parts. So 2 and 3/6 is the same as 15/6. 1 and 1/6 is the same as 7/6. So you take those away and you end up with 8/6 or 1 and 2 6, because you've done 2 minus 1, which is 1, 3 6 minus 1 6, which is 2 6. And can you just say to yourself, what fraction is 2 6 the same as? Times table of 2 and 6, both in that you could divide top and bottom by. It's 2, so 1 and 2 6 is the same as 1 and 1/3. Divide the top and the bottom of that fraction by 2. Right, so great time to pause here and have a go at questions 1 to 3 on the worksheet. Okay, so we're going to look at some very similar questions, the only difference being that they're now written in words rather than number sentences. So from Jack's house to school, it is 2 1/4 kilometres. From Jack's house to the park, it is 1 5/8 of a kilometre. How much closer is the park to Jack's house? So the school is 2 1/4. The park is 1 5/8. And we want to know that difference. So what number sentence are we going to write? Let's maybe write it down or just say it out loud to yourself. Let's work out the difference between those two. Okay, so we're going to have to do 2 1/4 minus 1 5/8. So have a think to yourself, what method are you going to use to solve that? And then have a go at going through that question. Right, so let's just move it so we've got a bit more space. So 2 1/4 minus 1 5/8. We need to make the denominators the same. So 2 1/4, what do you do to make it equal 8? You times it by 2. Whatever you do to the bottom, you do to the top. So 1 1/4 becomes 2 8. So now we have 2 and 2 8 minus 1 and 5 8. So you've noticed you've got 2 8. You can't take 5 from 2. So let's make that into improper fractions, and much easier because you know how many 8s you've got all together. So you do your 2 times your denominator, which is 16, plus numerator, which is 18. So 2 times 8, 16 plus 2 is 18 8. 1 times 8 is 8, plus 5 is 13. 13 8. So 18 8 minus 13 8 is 5 8. So the answer is 5 8. So the difference, how much closer, is 5 8 of a kilometre. Just check. So we're going to look at that question again in a different way. So here we have 2 and 2 8 represented in bar model, and we're going to take away 1 and 5 8. So what we've done here is we've used that exchange method, haven't we? Because if you try and take 5 from 2, there's not enough 8s. So we're going to exchange one of our wholes to 8 8s. And then what we've done down the bottom is we add our 8 8s to our 2 8s, we get 10 8s. So it's 1 and 10 8s minus 1 and 5 8s, which is 5 8s. Okay, so pause the video now. Have a go at these questions. So make those denominators the same. Decide if you want to make them into improper fractions before you take them away, or if you want to use the exchange method. So pause the video, have a go at those and see if you get the same answers as me. So let's look at the first one. So 5 and 1/10, take away 3 and 3/5. We need to make those denominators the same. How do you make 5 equal 10? You multiply by 2. Whatever you do to the bottom, you do to the top. So you have to do 3 times 2 as well. So change this fraction into tenths. So now we have 5 and 1/10 minus 3 and 6/10. Okay, so if we change that into improper fractions, so we don't have to worry about exchanging, we do our whole number times our denominator, 5 times 10, which is 50, plus 1, 51 tenths. 3 times 10, which is 30, plus 6, 36 tenths. So 51 minus 36 tenths is 15 tenths, and then you just want to convert it back to a mixed number. So how many 10s in 15? So 10, 20, so 1 10. You've used 10, you had 15, so 15 take away 10, that's 5. So 1 and 5 tenths. And you know there's another equal sign because you can simplify it. So 1 and 5 tenths. 5 is half of 10, so that's the same as 1 and half. Okay, the next one, 9 and 2/7 minus 7 and 6/14. Once again, you can make those denominators the same. You have to make those denominators the same. So if you multiply your 7ths by 2, the whole fraction, you get the denominators the same. So 7 times 2 is 14. 2 times 2 is 4. So now we have 9 and 4/14 minus 7 and 6/14. So we're doing the exchange method here. So what I'm going to do, I'm going to get rid of that for now, and I'll do this one up here. So 9 and 4/14 minus 7 and 6/14. So ignore the wholes for now. You've got 4/14. Take away 6. You can't do 4 take away 6, so you're going to have to exchange one of your wholes for 14ths. How many 14ths in a whole? Tell yourself. There's 14. So 14 14ths plus 4/14 is 18/14, and that is how I get this. So 8 and 18/14 minus 7 and 6/14. We do our wholes. 8 minus 7, which is 1, and then we do our 18 minus 6, which is 12. So 1 whole, 12/14. Oh, they're both in the 2 times table, so we can divide the top and the bottom of that fraction by 2 to simplify it. So we get 1 and 6/7. Okay, your activity has been assigned to you once again on Teams with the answer sheet, so check your answers against that answer sheet. This is just to see if you can recognise if you're making any mistakes, whether you need to watch a bit of the video again to recap it and just correct a question or two, or whether you need to come to the live feedback session so I can go through the questions with you. So really do use those answer sheets just to check so you can identify if you're making any mistakes. Thank you once again for all your hard work and for listening to the lesson. Speak to you soon.